Hey, hello everyone. So we left the last class with this shit. And apparently it looks like very bad, but there is a simple way to solve this problem. I learned this from one artist. His name is Adam Kath, and basically it's a point wrangle, and we need the point wrangle and the BDBs. So the point wrangle basically is gonna to see if any of these shared points are inside of the collider, who is gonna be BDB. And if the point wrangle detects that this point is inside of the collider, for example, this area, the wrangle is gonna take this point and it's gonna push outside. Okay? So let's do that. We can delete this merge. Let's create the attribute wrangle. And in the first input, which is the input 0, remember, we're gonna put the geometry we want to apply this push. And we're gonna create this push shirt. Okay? So after this, we are gonna create the BDBs. BDB from polygon. Okay, let's put it more or less here. Let's put it in the Keanu Reeves. And let's decrease the subdivision a lot, like something like 008. Okay, something like that. So once with this, we're gonna apply the fill interior. And we're gonna create a BDB reshape SDF. This basically is gonna make our Keanu Reeves like a little bit thicker. Okay? And we're gonna connect this into the second input, the input 1. And here we're gonna write down the magic. So first of all, we need to create a float. We're gonna call this dist, and this is gonna be equals. Now we're gonna create the expression of the volume sample. Let's put the volume sample here, and let's put 1, 0, and add P in capital letters and semicolon. Okay, I'm gonna explain this now. If you don't remember this expression, if you click here and you press F1, Houdini is gonna open the default documentations and it's gonna save your ass, okay? Because here it explains how it works and everything. So as you can see here, we need the geometry. In this case, the prim num it's 0, and we need the position, okay? So let's continue. And now, if we visualize as an attribute, let's create an f at dist equals dist. Let's put semicolon. If we check our spreadsheet, we will see that we have the attribute dist, and we have some values which are negatives. So negative means that it's inside, okay? Let's delete this, and let's create the second part. So now we need the vector, because we are gonna need to move. Because we want to create a gradient. So in order to create the gradient, we need a vector, because we need the x, the y, and z. So let's put vector. Now we are working in local, remember, because if we apply this, we are working in local. So these attributes are not gonna be transferred in the whole setup. So it's only gonna work in this wrangle. So let's put something like grad. Let's put equals. First of all, we are working with gradients. So it's good to normalize that gradient, which means bring the gradient from the 0 till 1. So it's like a remap. Let's put normalize. And inside the expression, let's put the volume gradient 1. And the same, if you don't remember, let's go to the Houdini documentation. But I told you, it's the same as the volume sample. Let's put 1, let's put 0, and let's put at p. Okay, and let's close it with semicolon. If you want, you can check this as a vector, as I showed you before with the dist. But once with this, what we are going to do is we are going to create the if statement. So if the dist is smaller than 0, so it means it's negative, what's going to happen? Let's put the conditions here. So first of all, we need to push this outside, right? So what we need to change is the position of the point. So we are going to put at p in capital letters. It's less or equals that dist multiplied by the grad. Let's put the semicolon. And this is going to work. As you can see here, now if we merge this, with our Keanu Reeves, we're going to see that we are not having the intersections. Of course, we can reduce this delay a little bit. Something like this. Okay. And then we're going to fix this with a peak. Let's put it something like 0.221. Okay. And then with a peak, we're going to push a little bit out the geo. Let's put 0.003, something like that. Cool. Now it's working. Maybe we can just reduce it a little bit. Something like this. Yeah, I like it. So cool. Just check with and without the expression. With or without you. Cool, so it's working. So once with this, let's do maybe a flipbook to check that everything is working. Because this wrangle is going to apply in every frame. So every frame that this wrangle detects that one point is inside the VDB is going to push it outside. So see you in the next lesson.